Welcome to our exploration of quantitative problem solving, where numbers become practical solutions. In this presentation, we'll discover how mathematical reasoning cuts through complexity, uncovers patterns, and turns raw data into decisions you can act on. Think of this as a roadmap to using numbers smarter, whether you're solving business challenges, scientific puzzles, or everyday quantitative questions. Quantitative reasoning is the backbone of modern decision-making, helping teams move from confusion to confident action. In the image, we see analysts collaborating over charts. This teamwork and data literacy let organizations identify trends, test hypotheses, and make predictions with measurable certainty. By treating numbers as a shared language, we translate complexity into clear, actionable next steps. Numbers have guided problem solving for millennia, from Babylonian land division to wartime code breaking and today's AI models. Each era borrowed mathematical tools to meet its urgent problems, and that continuity shows why quantitative thinking remains essential. The timeline reminds us that whether in ancient fields or modern labs, disciplined numerical reasoning consistently converts uncertainty into progress. Breakthroughs often arrive as a sudden moment of clarity after persistence and pattern recognition. That eureka instant is where disparate observations snap together into a simple explanation, and a path forward appears. It's a reminder that rigorous work, patient testing, and openness to new perspectives create the conditions for those decisive insights to emerge. Quantitative problem solving blends mathematical application, evidence-driven choices, and integrated thinking to tackle real-world issues. We apply formal methods to model situations, use data to remove guesswork, and combine logic with judgment to navigate complexity. Together, these elements turn abstract concepts into practical steps, helping you make decisions that are both precise and useful. A classic framework for tackling problems comes from George Paglia and his 4 steps. Understand the problem, develop a plan, carry it out, and then look back and reflect. This method turns overwhelming tasks into manageable phases, encouraging careful reading, strategic selection of tools, methodical execution, and learning from the results to improve future approaches. Every quantitative challenge has layers of information that must be peeled back and examined. Successful solvers act like detectives. They identify what's given, clarify what's sought, and decide which tools bridge the gap most efficiently. Gathering evidence, testing hypotheses, and reconstructing the story behind the numbers leads steadily to resolution rather than guessing at answers. Here's a practical case. A mayor facing a budget shortfall used quantitative analysis to identify a multi-million-pound gap, break down income and spending streams, and verify projections with rigorous data checks. That structured approach exposed inefficiencies, guided targeted interventions, and ensured decisions were grounded in verifiable evidence rather than assumptions or political noise. Numbers can't be trusted until their assumptions are tested, and the most dangerous phrase in business is assuming figures are correct. Missing context, hidden biases, or unit mismatches can all derail conclusions. Before acting, question your inputs, validate sources, and look for what's not obvious. Only then can the numbers truly support confident decisions. Clarity begins by separating knowns from unknowns. Start with careful reading to capture every relevant detail, label variables consistently, convert units where necessary, and choose equations that match the problem's structure. These foundational steps prevent trivial errors and lay a stable groundwork so subsequent calculations are meaningful and verifiable. When word problems hide their maths, the cube strategy brings order. Circle key numbers, underline the actual question, box operation words, eliminate misleading details, and then solve systematically. This disciplined approach reduces narrative noise, keeps your focus on what matters, and ensures your working is clear and checkable for both results and learning. Choosing how to attack a problem matters as much as the maths itself. Sometimes a brute force calculation is fine, other times an elegant transformation saves time and error. Consider speed, accuracy, and resources when selecting your method, and be ready to switch strategies if a chosen approach proves inefficient or fragile under scrutiny. Different tools suit different situations. Algorithms give step-by-step certainty for high-stakes problems, heuristics offer speedy approximate answers when time is short, trial and error helps discover solutions through iteration, and sudden insight sometimes replaces lengthy logic. Knowing the trade-offs between these approaches lets you pick the right tool for the problem at hand. Visualization can reveal structures that pure equations hide, so draw diagrams, add reference lines, or reframe the problem to expose symmetry and relationships. A fresh perspective, rotating or simplifying the view, often uncovers shortcuts or clarifies dependencies, making complicated interactions far easier to reason about and communicate to others. Mathematical modeling turns abstract theory into useful predictions. Linear optimization helps allocate scarce resources efficiently, stochastic models embrace randomness for realistic forecasts, and differential equations capture how systems evolve over time. Each technique has strengths and trade-offs, and choosing the right model depends on the question you want the numbers to answer. During a health crisis, epidemiologists use models like SIR or agent-based simulations to predict how a virus might spread and how interventions change that path. Real-time data feeds inform policies like vaccination campaigns or targeted restrictions, and the difference between model-informed action and guesswork can be measured in lives saved and resources preserved. When seconds matter, quantitative reasoning shifts from useful to essential. In high-pressure environments like critical care, rapid numerical estimates and clear protocols guide life-saving choices. That pressure sharpens the need for simple, reliable methods that reduce cognitive load while preserving accuracy, because precision under stress defines excellence in such settings. In hospitals, every calculation carries consequences. Clinicians may have only seconds to compute drug dosages, tiny percentage errors can turn effective treatment into harm, and intensive care staff make hundreds of quantitative decisions each shift. These figures highlight why rigorous numerical habits, immediate verification, and error-aware thinking are vital in medical practice. Root cause tools like the fishbone diagram and the 5 whys help teams move beyond symptoms to systemic solutions. Mapping potential causes across categories exposes overlooked pathways, while repeatedly asking why peels back layers until the fundamental problem surfaces. Together, these techniques prevent quick fixes and encourage fixes that address core contributors. Looking back, numbers have reshaped our world by turning curiosity into clarity and chaos into control. Every scientific or technological leap begins with a problem and the courage to engage with quantitative complexity. Your next eureka may come from a spreadsheet, an equation, or a new dataset, and with disciplined thinking, those numbers can change everything.